Hello, boys and girls. This is Ms. Coville, and this lesson is for all 5th graders at Bethune Elementary. Today, I am teaching this lesson on classifying two-dimensional figures to students both in my class and Mr. Moore's class. Please make sure you stop and jot notes as you view this video. Today's standard says that students will classify two-dimensional figures in a hierarchy based on properties, polygons, triangles, and quadrilaterals. By the end of this lesson, it is expected that you'll be able to create diagrams classifying 2D figures. Throughout this lesson, you will hear me use, as well as see in your iReady lesson, terms like polygons, parallel, quadrilateral, parallel, and right angles. Please take a few minutes to jot down these words and definitions so you can use them to help you later in your constructive response items. You may also draw examples of each of them to help you remember and understand them better. Now in front of us, we have our vocabulary. Our first vocabulary word is polygon. A polygon is any two-dimensional shape formed with straight lines. So we have a triangle, a pentagon, a hexagon, and quadrilateral. And the picture below shows 7 different types of quadrilaterals. These are examples of what a polygon is. So please write these down and draw the pictures that go along with each example. Pause the video and do so at this time. Our other vocabulary words are parallel. Parallel means two straight lines that do not meet. And in our example photo, we have 2 pairs of parallel lines. And we see that neither one of these lines touch one another or meets. So this is a parallel line. A parallelogram has 2 parallel sides. Each opposite sides are of equal length. Opposite angle is less than 90 degrees. So we have 2 sets of parallel sides. We have one set of parallel sides right here, and another set of parallel sides that are of equal length. And this angle within this parallelogram is less than 90 degrees. Now a right angle is an angle of exactly 90 degrees. And right here we see a picture of what a 90-degree angle will look like. So as we go through this lesson, make sure you go back and you reference these vocabulary words to assist you in your questions. All right, so let's get started. We are currently on lesson 30, classify two-dimensional figures, and this is on page 300 of your packet. And in this lesson, you will classify polygons based on their properties. So we're going to take a look at this problem. The problem tells us to arrange the polygons below so that a polygon can be also called by the name of the polygon before it. So we're going to order them from left to right. But before we can order them, we're going to complete the table below. Put a check in each box if the polygon has the property listed. So in our table, in this first column of our table, has various descriptions for our polygons. So we're going to look at each polygon and we're going to see which one of these fit each description that's given to us. So let's get started. Our first description, which polygons have 4 sides? So let's take a look. We have our first polygon A. It has 1, 2, 3, 4 sides. So that fits the criteria. So we can go ahead and put an X in polygon A. So let's go ahead and do so now. Polygon B. It has 1, 2, 3, 4 sides. It also fits the criteria. So we can put an X in that box. And polygon C has 1, 2, 3, 4 sides. Polygon C also fits that criteria. Now let's look at the next description. 2 pairs of parallel sides. Again, our vocabulary word parallel means that they are 2 straight lines that do not meet. So let's check our polygons. Our first polygon A, it has 1 pair of sides and another 2 pairs of sides. And each pair do not meet one another. So that means this line and this line do not meet one another or touch. So that is one pair, and this line do not touch or meet one another. So that fulfills that description. Let's look at polygon B. We have one pair of sides that are parallel, and we have another pair of sides that are parallel. Again, each line on each side does not meet or touch one another. So polygon B fits the criteria. And polygon C, yes, it does. It has two pairs of parallel sides. The next description says, two pairs of sides of equal length. So let's look. Both of these sides are of equal length? Yes. Both of these sides are of equal length? Yes. So polygon A fits the criteria. Polygon B, these sides are of equal length? Yes. These sides are equal length? Yes again. We're going to put an X in that box. And our last one, these sides of equal length? Absolutely. These sides of equal length? You gotcha. So let's go ahead and put a check or an X in that box. Now our next descriptor, 4 right angles. So let's look back at our vocabulary, which you should have written down. A right angle. So a right angle is an angle of exactly 90 degrees. And this is what a right angle should look like. So let's look back at our shapes to see which polygon has right angles. Alright, so let's see which of our polygons have right angles. Let's look at A. This looks exactly what my vocabulary example looked like. Yes, that is a right angle. It's exactly 90 degrees. All 4 sides have right angles. So I have 4 right angles in polygon A. So I can mark off polygon A. Let's look at polygon B. This does not look like a right angle, because if it was a right angle, it will be on this line right here. This is less than 90 degrees. So I can automatically say B does not have 4 right angles. If I know that this angle right here is not 90 degrees, then it does not have 4 right angles. Let's look at polygon C. This is a square, and it has 1, 2, 3, 4 right angles, and it fulfills the description. Now let's go to our last one. 4 sides of equal length. Now, polygon A, it has these 2 sides are of equal length, and these 2 sides are of equal length, but not all 4. Let's look at B. These 2 sides are of equal length, and these 2 sides are of equal length, but they not have all 4. Let's look at C. 1, 2, 3, 4. All of these sides are exactly of equal length. So C, polygon C, is the only polygon that fulfills this criteria. Make sure you press pause and jot down all of these notes in your packet at this time. B now asks us to write the most specific name for each polygon from the list below. So we have 4 options. We have quadrilateral, parallelogram, rectangle, and square. And we are going to give each of our polygons above a specific or the most specific name. So let's look at polygon A. Polygon A is a rectangle. So I'm going to write down rectangle in polygon A right here. Polygon B right here. Polygon B. Now we have quadrilateral left, we have parallelogram left, and we have a square. So let's look back at our vocabulary and let's see what might polygon B be. Based off of my definition and the example given, I know that polygon B is an example of a parallelogram. So I will write parallelogram in B. And polygon C, we all should know that polygon C is indeed a square. So we're going to write square for polygon C. Make sure you are taking down your notes and writing down every answer that I have placed on the screen. Do so, press pause and do so at this time. C says, how would you arrange the polygons so each shape has all the properties of the shapes before it? So that means I'm going to arrange each polygon, polygon A, B, C, and I'm going to look at my table above. And I'm going to see which polygon has the least amount of fulfilled descriptions. And I'm going to write that first. And then I want to see, which polygon has the next most amount of descriptions filled. And then I'm going to find the polygon that has all of the descriptions filled. And that's how I will arrange my polygons so that each shape has all the properties of the shapes before it. So on your own, press pause and write down the order that you feel your polygons should go in based on the table above. So you should have written polygon B, or parallelogram, which is what we identified it to be, first, because that had the least amount of properties that were fulfilled. Then the next one will be rectangle, which is polygon A, that had the next greatest, and polygon C, which was a square, had the most fulfilled properties. Let's turn to the next page. Shapes can be classified according to their properties. When you order categories of polygons by their properties, you put them in a hierarchy. A hierarchy organizes categories from the most to least general. One model you can use to show a hierarchy is a Venn diagram. A Venn diagram can show categories and subcategories. This Venn diagram shows that squares have all the properties that rectangles have, plus more. This means all squares are also rectangles. A square is also a parallelogram and a quadrilateral. So we have our Venn diagram here. So the most specific item will go in the center of our Venn diagram. And the most general category would be our outside layer. So our most general category is a quadrilateral. And then we know that parallelograms are one type of quadrilateral. So a parallelogram is our next category. And then a rectangle is our next subcategory, because I know that a rectangle is a parallelogram and a quadrilateral. And the square is the most specific subcategory. You can also use a flow chart to show the hierarchy of quadrilaterals. The most general category is at the left, while the most specific is at the right. This means that a figure that belongs in one category also belongs in all categories to the left. Let's take a look. All right, so let's look at the flow chart below. So it shows that the most general category, which is the quadrilaterals, will be to the far left. So quadrilaterals is to the far left. And I placed an anchor chart here for us to help us understand how we can categorize our terms. So the quadrilateral is the largest category. So that goes to the far left. The parallelogram will be the next to the largest subcategory. So we have parallelogram, and then rectangle will be the next subcategory, and square will be the most specific, and that will go at the end. So at this time, we're going to reflect. How are the flow chart, which is right here, and the Venn diagram, which is right here, alike? And how are they different? So pause the video, and you're going to write your reflection in complete sentences in this space below. Pause the video and do so now. So your response should say the flow chart and Venn diagram are alike because they order quadrilaterals first and squares last. They are different because the Venn diagram has a larger area for the largest category, and the flow chart shows each category in the same sized box. Let's turn to the next page. We will now continue to explore different ways to classify figures in a hierarchy. We're going to classify the following triangles from the most general to the most specific: scalene triangle, isosceles triangle, and equilateral triangle. Use a tree diagram to classify them as types of triangles. And to our right, I have an anchor chart to specify and show us the difference between each different triangle. So model it tells us that you can understand the problem by listing the properties of the triangles in a table before arranging them in a tree diagram. So I know that an isosceles triangle has 2 or 3 sides of equal length. All triangles have 3 sides. So an isosceles triangle, which we have right here on our anchor chart, has 2 or 3 sides of equal length. So this isosceles triangle has 2 sides of equal length, because this side is longer than both of those sides. A scalene triangle, no sides of equal length. So we have a scalene triangle right here, and each side of the triangle has a different length. And an equilateral triangle, all 3 sides have the exact same length. And we see an example right here where all 3 sides of this triangle have equal length. So let's move on to our model it. So it says you can represent the problem with a tree diagram, which is right here. A tree diagram can also be used to show a hierarchy. Put the most general category as the top branch. Then put the more specific categories as sub-branches. So our most general category is triangles, because we know that all 3 of these types of shapes are triangles. So that will go in our top branch because it's the most general category. Now we need to split them up into subcategories. So let's think, what should I put for my first subcategory? So I'm going to label my first set of subcategories as scalene and isosceles. Now, if we think back to our previous pages that we looked at when we broke up our quadrilaterals into subcategories, scalene and isosceles, scalene does not have equal sides, and isosceles triangle has only 2 equal sides. Now, the most specific of all of our triangles is an equilateral because it has all 3 equal sides and will fulfill all of the property categories. And an equilateral is the most specific type of triangle. So we're going to put that here in our last subcategory. So our tree diagram should look as follows: scalene, isosceles, which are the first set of subcategories, and equilateral, which is the most specific type of triangle. Let's turn to the next page. So question 2 says, why is triangles in the top row of the tree diagram? So as previously stated, that triangles is the most general category, which is why it is at the top of our tree diagram. So let's go ahead and pause the video and write your response in the space below. So again, don't forget to restate your question, boys and girls. So your answer should say triangles is in the top row of the tree diagram because it is the most general category. Question 3 says write scalene and isosceles in the second row of the tree diagram at the right. then we will tell why are those categories separate. So think to yourself and identify in the space below and write down why are those categories separate. Press pause and do so now. So you should have written scalene and isosceles in both boxes, and your response should say, these categories are separate because a scalene triangle cannot have sides of equal length, nor can an isosceles triangle. Let's go to number 4. Write equilateral beneath isosceles. So we're going to write equilateral right here. Why can all equilateral triangles be classified as isosceles triangles? So think to yourself, why is an equilateral underneath an isosceles triangle? Go ahead and write your answer in the space below. So your answer should state, an equilateral triangle can be classified as an isosceles triangle because they have at least 2 sides of equal length. So if I were to put equilateral under scalene right here, they have no properties that are similar. A scalene triangle has no equal sides, but an isosceles triangle has 2 equal sides, so there are no similarities for me to put them in the same category. Now, if I were to look at an isosceles triangle and an equilateral triangle, they both have at least 2 equal sides. So that is why I would put equilateral as the most specific within my triangle category. Let's go to question 5. How can you use a tree diagram to order figures? Think to yourself, how do we use this tree diagram to order our triangles? Press pause and write your answer in the space below. Your response should read as follows. I can use a tree diagram to order figures by placing the most general category of a shape at the top of the diagram and more specific subcategories of shapes beneath. Let's go to the last question. So we're going to complete the Venn diagram below to show the hierarchy of isosceles, scalene, and equilateral triangles based off of what we learned in the questions above. So we identified that a scalene triangle would be in a category or a subcategory by itself. So within our Venn diagram, we see that the large box is the most broad category, which is triangles. Scalene, right here, we will put it right here. It is a subcategory. And we know scalene triangles have no equal sides. So it's in the category by itself. Now this subcategory, we identified it to be isosceles. And the most specific of them all would be equilateral. Make sure you're writing this down in your packet at this time. Now, boys and girls, you will be working on your own on pages 304 through 307. And be sure to look back at the anchor charts in this video to help you identify the definitions and the examples of each shape.